Good day, class. Welcome to our channel. Today we're going to be treating the continuation of the class on partial fraction. So, in the first class, we talked about partial fraction, we defined it, and the example we used there was based on linear factors, where we have f of x over x plus a, x plus b, x plus c. But in this case, I want to use a more complex example to explain some principles, also in linear factors. Then after that on linear factors, we'll solve examples on repeated linear factors. So examples are going to make these things clearer to us. So with this now, we have equal to, this is the question, to resolve this, we are resolving this. So this is equal to a over, we don't have anything here, a over, so since we don't have anything there, that means we are going to factorize this. Are you following? You know, in the previous class, we have factors in the what? Bracket. Something like x plus a, x plus b, was in the bracket. But in this case now, we don't have anything of such. So what we are going to do first of all is to factorize the denominator. So we say factorize denominator. When we factorize denominator, we are having x squared plus x squared minus x minus 2 is equals to, the coefficient of x squared is 1. So I multiply 1 times minus 2, giving me what? Minus 2. Now what are the factors of minus 2? Now when I add them, I have minus 1. And when I multiply them, I have minus 2. When I add, I have minus 1. And when I multiply, I have minus 2. Those factors are what? They are, we have 2 times minus 1. 2 times minus 1 will give you minus 2. 2 plus minus 1 will give you plus 1. So it did not work. We say minus 2 times plus 1. So minus 2 times plus 1 will give you minus 2. Minus 2 plus minus 1 plus 1 will give you minus 1. So we are going to use these two factors. We have x squared minus 2x plus 1x minus 2 equal to 0. So we factorize this, you have x open bracket, x minus 2 plus 1 open bracket, x minus 2 equal to 0. So look at this, the two of them here are the same. Therefore, we choose one out of the two of them. Say x plus 1 and x minus 2. We have factored it out like this. So this will now, we are bringing back our fraction now to be 4x minus 5 over x squared minus x minus 2 is equal to a over x plus 1 plus b over x minus 2. So with this, we are having, remember that the multiple of this and this is giving you this. So they can actually cancel themselves. But before that, let's look for the what? The LCM of both of them. The LCM of both of them is still what we have here, but in the factored form as x plus 1, x minus 2. And this is what? 4x minus 5 over x squared minus x minus 2. Always remember that this and this are the same in this case, because it is from here we factorize it to give us this. We factorize everything to give us this. So since we have factorized it to give us this, it is this thing here is the same as this thing here. Let me explain it somewhere here. We have x plus 1 and x minus 2. Let us check if it is actually the same as this. We choose x open bracket x minus 2 plus 1 open bracket x minus 2. X times x squared. X times minus 2 is what? Minus 2x. This time this will give you what? Plus x. And this time this will give you what? Minus 2. Therefore, you have x squared minus x minus 2 you can see that this and this are the same. So that if I'm using this, I can use it to replace this. So I have this divided by this will give you what? Give you x minus 2. So you have a open bracket x minus 2 plus b open bracket x plus 1. So since they are the same, they will cancel the denominator. So we equate the what? Equate the numerator. Equate the numerator. So since we have to equate the numerator, we're going to have equate the numerator by we are having this and this. We have 4x minus 5 is equal to a open bracket x minus 2 plus b open bracket x plus 1. Now, to remove this, we are going to use what? We're going to say that our let x equal to 2. Why? We want to make this whole part become 0. So because we want to make it become 0, we're going to say, what are we going to use to substitute x so that the whole of this will be 0? The easiest way to know that is just to equate this part to 0. We say x plus 2, x minus 2 equal to 0. Therefore, you say x equals to what? 2. Since x is equal to 2, you say let x equal to 2 to remove this part of the equation. So if x equal to 2, you say we have 4 open bracket 2 minus 5 equal to a open bracket 2 minus 2. You see 2 minus 2 will give you 0. So the whole of this part is gone to 0. Plus b open bracket 2 plus 1. 2 plus 1 is what? 3. So you have 3b equals to 8 minus 5. And 3b equals to 3. Therefore, b will be what? B will be equals to what? B will be equals to what? 1. So we are going to go on a short break and continue the solution to this after the break. Thanks for watching. Welcome back to the channel. Now, we are continuing with this calculation. We have gotten the value of b to be 1. Now I want to look for the value of a here. So what we'll do is to eliminate this, and to eliminate it, I've taught you how to do it before using this kind of example. With that, I know that x is equal to what? Minus 1. So we have let x equal to minus 1. If x is minus 1, I have 4 open bracket minus 1 minus 5 equals to a open bracket minus 1 minus 2 plus b open bracket minus 1 plus 1. So this part becomes what? 0. And I have minus 4 minus 5 equals to minus 3a. Divide both sides by what? Minus 3. And a equal to minus 9 over minus 3, which is equal to 3. So we can see that this equation here, at this, is now equal to 3 all over x plus 1 plus b. B in this case now is what? B is 1 over x minus 2. So with that, when you solve, if you add these two fractions, you still get the same value as your final answer. So this is the answer to that question. So we are going to continue now for solving for repeated linear factors. As I told you, repeated linear factors. Questions for repeated linear factors. I'll use a small example here. We have, let's say, 5x plus 1 over x plus 1 square. Let's take it this way. 5x plus 1 over x plus 1 square. So in this case, we have equal to a over x plus 1. Next is what? Plus b over x plus 1 square. That is how you solve this type of question. Now, having repeated means it is going to come 2 or 3 times. If you follow this pattern I'm giving you, any amount of times they give you, if it's something like this, x to the power 3, you write x plus 1, x plus 1 square, x plus 1 cube. You do it that way, you get your answer. So, but because of time, let us solve something like this, and we're going to get our answer. So for this, we're having the LCM here now is what? X plus 1 square, right? You know, your normal x LCM. LCM of x plus 1 and x plus 1 square. You have x plus 1. Cancel this, give you 1. Give you x plus 1. And x plus 1 again, give you what? 1, 1. So this time, this is x plus 1 square. That's a side note. This divided by this to give you what? To give you x plus 1. So x plus 1 times this is a open bracket x plus 1 plus b x plus 1 square divided by x plus 1 square is 1. So there's nothing you're writing here. It's equals to 5x plus 1 over x plus 1 all square. This will divide this. So it equates the what? The numerators now. So equating them, we have equate numerator. To equate your numerator, you have 5x plus 1 equals to a open bracket x plus 1 plus b. With this, I say I want this guy to leave. So I say let x equals to minus 1. If x is equals to minus 1, I have 5x plus 1 is equals to a open bracket minus 1 plus 1 plus 1 plus b. So this guy becomes what? 0. So 5x, putting our x now to be also minus 1 here, plus 1 equals to b. So what is b? 5 times minus 1 will give you what? Minus 5. So minus 5 plus 1 is what? Minus 4. Minus 4 equal to what? B. I'll solve for b. Let us solve for a. Let us solve for a. So solving for a, we're going to say that, going back to this place, 5x plus 1 equals to a open bracket x plus 1 plus b in this case now is minus 4. So I say minus 4. So I open this bracket, I say 5x plus 1 equals to what? Ax, right? Ax plus a, ax plus a minus 4. Now, coefficients, those that have the variables attached to them, now we're going to equate them. Now this guy is having x here, and this one is having x also here. So I'll say that what? 5x is equals to ax. Divide both side by what? Divide both side by x. Therefore, a is equals to 5. So we're going to write our answer and still test it. If we are correct, we'll know. If we are not correct, we're going to know. That's why mathematics is unique. If you are correct, you will know. If you are not correct, you will know. So now we'll solve this. You say that this 5x plus 1 over x plus 1 square is equal to a is what? 5 over x plus 1, and b is what? Minus 4 over x plus 1 square. Plus times minus is what? Minus. So I can put my minus here. Now let's test it. We are testing your answer to know if it's correct. You know, when you finish cooking your soup, you test it to know if it's sweet. So this one, I want to test it to know whether what we have been doing since is correct. So look at it this way. We say 5 over x plus 1 minus 4 over x plus 1 square. LCM is x plus 1 square. This divide by this is what? X plus 1 minus 4. So that gives you 5x plus 5 minus 4 over x plus 1 all square. That is 5x plus 1 over x plus 1 all square. You can see that this and this are the same. So this is our answer for what? Resolving to what? Partial fractions. You are correct. So thank you very much for watching. We are going to be having the one that have quadratic factors in the next class. Quadratic factors will be in the last class of partial fraction, will be in the part 3 of it. So we want you to please subscribe to our channel, watch, like, and share with your friends. It's not good for you to just learn these things and hold it to yourself. Please, if you have those that want to write WAEC, JAMB exams, or persons in the year 1 in university that will have that will need something like this, we are going to be treating some year 1 topics in the university also. So we advise that you please tell them to subscribe to our channel, as we're going to be dropping a lot of resources on that, video resources on that. We're going to be giving them a lot well explained in details. So please help us share the good news of Leaders Academy. Thank you very much, and God bless you. In our next video, we're going to see